Hello friends, once again we begin with topic of physics, in which we have begin with the chapter of current electricity, and we already discussed in previous lectures about the Kirchhoff laws, then Western bridge, then potentiometer and their applications. Now in this lecture we have a very small topic of comparison of voltmeter and ammeter, and again we have one more small topic, that is of the thermoelectricity, and then we begin with the solution of unsolved problems. So we are going to understand in this lecture the how to solve the numerical problems on this chapter. Now check the presentation. Check carefully. So here we have the comparison of ammeter and voltmeter. So in last lecture we already discussed the conversion of galvanometer into ammeter as well as into voltmeter. Now check the point of difference. Number first point. So we already know the ammeter measures the current, and in case of voltmeter it measures potential difference. Number second, so here important part, voltmeter measures potential difference. Now number second, it is connected in series. So we already know the connection of ammeter in circuit, it is always connected in series, and exactly opposite, voltmeter connected in parallel here. So that is number second point of difference. Number third, that we learned in previous lecture, it is in case of ammeter, it is an MCG moving coil galvanometer with low resistance, and in case of ideal condition, ideal is zero. Now number third, in case of voltmeter, it is moving coil galvanometer with high resistance, ideally infinite. So that we have understood in case of last lecture of conversion of galvanometer into ammeter as well as voltmeter. Also we have explained the construction in which we have given number 4 point. Smaller the shunt, greater will be the current measured. Exactly opposite, larger its resistance, greater will be the potential difference measured. So depend upon two values. Shunt resistance means parallel resistance. That value should be as small as possible. And in case of voltmeter, we have series resistance, and that resistance should be as large as possible. So this will be the connection to the galvanometer to convert ammeter as well as voltmeter. Now number 5th point, we have the formula. Resistance of ammeter is, so this RA, ammeter resistance, is equal to S into G divided by S plus G. That formula is according to parallel connection of G and S. So when shunt resistors S and G are parallel to each other, then we have formula 1 upon Rp is equal to 1 upon R1 plus 1 upon R2, or we write Rp is equal to R1 into R2 divided by R1 plus R2. So accordingly we have that formula, and in terms of N times G upon N. Similarly we have voltmeter. Resistance of voltmeter is Rv and G plus X. So galvanometer resistance G and series resistance X, that connected in series, so we have addition of resistance according to series formula Rs is equal to R1 plus R2. So this will be addition, or suppose N times NVG into NV, like this. So this is the comparison. A small question may be asked to compare the ammeter with voltmeter. Okay. Now we have the next small topic of thermoelectricity. So what is according to the definition or understanding? When electric current is passed through a resistor, electric energy is converted into thermal energy. So this is according to the concept of resistance. So the electrical energy, when current flow through resistor, because of that resistance, there is a charge or electrons lose the energy, and that lost energy is converted into thermal energy. So this is thermoelectric effect, or this is Joule's effect. Current flow through the resistor, energy is converted into thermal energy. Now the important part on the second point, the reverse process, conversion of thermal energy directly into electrical energy was discovered by Seebeck, and the effect is called thermoelectric effect. So the reverse process means thermal energy converted into electrical energy, that is called the Seebeck, or discovered by Seebeck, and corresponding effect is called thermoelectricity. So we have an example of the Seebeck effect. Check carefully. When two different metals are joined to form closed loop. Closed loop means there are two junction points or 2 points where the two metals will be joined, and we have one loop. And these junctions are kept at a different temperature. A small EMF is produced and current flow through the metals. This EMF is called thermo-EMF. This effect is called Seebeck effect, and the pair of dissimilar metals forming the junction is called thermocouple. So let us, we have an example of the antimony-bismuth. Thermocouple is as shown in diagram. So see carefully. We have the hot junction and the cold junction. So there is a junction of bismuth and antimony. Bismuth Vi, antimony Sb. Their first junction and second junction. One junction is kept in high temperature and one junction is kept at low temperature. So we have, suppose the water is considered in case of first junction, hot junction. We heat that water, and so that the one junction get hotter or hot junction. And second, if we kept in ice, so ice as a cold junction, so that junction is deep in ice, so that is cold here. And when we connect this condition or this particular pair of metals, so Sb is connected to the galvanometer and again goes to the junction here. So check carefully, there are two metals Vi and Sb. If we connect in this case, so there is no source of electricity. So when first junction came in hot junction, second junction cold, then current start flowing from bismuth to antimony, or from cold junction antimony to bismuth. So this will be the direction of current, and galvanometer can record the or sense the current when current flow through that particular circuit. So for this thermocouple, current flow from antimony to bismuth at cold junction. So we have ABC rule here, simply antimony to bismuth, A to B, and C for cold junction. So here we have Sb antimony, bismuth, and cold junction A to B here at cold junction. So this is simple rule, and now we have begin with. So this will be the one pair of metals. In case of textbook also we have given another example of copper and iron also. For that also it is applicable here. So check the textbook. We have another also same type of example for copper and iron here. Now let us begin with the unsolved problems from textbook. So we'll first of all read the problem, try to write down the given, try to understand what we have given and what we have to calculate. Now check number first. Suppose two cells of EMF 1.5 volt and 2 volt having respective internal resistance of 1 ohm and 2 ohm are connected in parallel so as to send current in same direction through an external resistance of 5 ohm. Find the current through the external resistance. So check carefully once again. Now we one by one extract the given here. 2 two cells of EMF 1.5 and 2. There are two cells are given. The respective internal resistors also given 1 and 2 connected in parallel. So see, we have in circuit 1.5 volt and 2 volt, and the internal resistors 1 ohm and 2 ohm are connected parallel. So these will be parallel, positive connected to positive, negative connected to negative. This is called parallel connection, and connected so as to send current in same direction. So current I1 and I2 will be same direction, and that current flow through the external resistance of 5. So here we have below 5 ohm resistance. So I1 flowing in this direction, I2 flowing in this direction, addition of I1, I2, that I1, I2 flow through the 5 ohm resistance, and then the particular current will be separated at E point as I2 as well as I1. So we design the circuit diagram by using the given data. Now we have following point A, B, C, D, E, F, A, corresponding internal resistance R, small r1 suppose as 1 ohm, small r2 as a 2 ohm, and external resistance suppose 5 ohm, and then EMF 1.5, 2 volts like this. And we mark the current I1 through first cell, I2 of second cell, addition of I1, I2 at point B, and that flow through the 5 ohm. Now check carefully the solution of this problem. Let the current through the various arms of the network be as shown in figure. So we first of all mark the currents and direction of currents and corresponding values of resistance and EMF. Now using Kirchhoff's second law for the loop A, B, C, D, E, F, A, B, C, D, E, F, A, that total complete large loop we have to consider. And for that we have to apply Kirchhoff's second law here. So check carefully, the A to B, then B to C, there is no component. Now from C to D, we have 5 ohm resistance, and from that the current is suppose I1 plus I2. Now we traveling in one direction, and the current is also same direction. Suppose we take it as minus sign. So minus I1 plus I2 into 5. Then second, from D to F, there is no component. From F to A, we have resistance 1 ohm and current is I1. Again, we have negative sign, minus 1 times I1. Then we have jump from negative to positive of cell. So we have taken sign positive plus 1.5 V, that is equal to 0. And when we solve, the EMF taken on one side and current and resistance taken on another side, then we obtain this equation. Check carefully. So this sign will become positive on other side. So we have EMF on one side and potential difference on other side. So that sign will be positive 5 times I1 plus I2 plus 1 into I1, that is equal to 1.5. By adjusting this equation, we obtain this equation. Now check carefully, if we multiply 5, so 5I1 plus 5I2 plus 1I1 equal to 1.5. So I1 become 5 plus 1, 6I1 plus 5I2 is equal to 1.5 as equation number first. Now same thing we apply for second loop. Check carefully. For the loop B, C, D, E, B, we have 5 times I1 plus I2, B, C, D, E, B. 5 times I1 plus I2, then plus 2 times I2, 2 ohm resistance, current will I2, 2 times I2, and again that is equal to 2. So check carefully, for B, C, D, E, B, we have 5 times I1 plus I2 plus 2 times I2, that is equal to 2. So this will again we adjust the signs so that we obtain this equation. Now if you multiply by 5, so 5 times I1 plus I2, 5 plus 2, 7, 7 times I2 equal to 2 here. That is equation number second. Now we are going to solve these 1 and 2 equation. So by solving, so we have already learned in mathematics, suppose there are 2 terms A and B, and that equations we are going to solve as quadratic equations. So by solving these equations for I1 as well as I2, so that can be done by matching the one of the terms. So here we have suppose uh, 5 times I2 and here 7 times I2. So suppose if you multiply equation 1 by 7 and equation number 2 by 5, so 5 into 7 35, here to 7 5 is 35. I2 will be term same, so that we have obtained equation for I1. So like this we have number of methods, and accordingly we have the solution I1 is equal to 1 upon 34 ampere. And similarly, using I1 value in one of the two equations, I2 will be obtained as 9 upon 34 ampere. And the total current will be I1 plus I2, that is flow through external resistance, that we are going to found in the question here or problem. So I1 plus I2 is equal to 1 upon 34 plus 9 upon 34, so 10 upon 34, that is equal to 5 upon 17 ampere. So I here minimize steps. You have to write down yourself and try to solve the remaining steps here. So in short, we have taken the solution here, and the solution is depend upon the mathematical part. That is not much difficult here. So you can solve by matching one of the term, either I1 you have to match or I2 you have to have match, so that you obtain the current either I1 or I2. So accordingly we solve the first problem here. Now similarly, the second or next problem, what we have given, check carefully. A voltmeter has a resistance 30 ohm. What will be its reading when it is connected across a cell of EMF 2 volt having internal resistance 10 ohm? Very easy problem we have given. Voltmeter has a resistance 30 ohm. What will be its reading when it is connected across cell of EMF 2 volt having internal resistance 10 ohm? So what we have given, check carefully. So we have to find reading of voltmeter. Now check carefully, voltmeter connected to cell having EMF 2 and also it has certain internal resistance 10. Now if we connect the voltmeter to a source or EMF cell having EMF 2 volt, then we have total current I is equal to E divided by R plus R. So I current flowing through the circuit, E EMF of the cell divided by R means external resistance, or here we have resistance of voltmeter and small r is internal resistance of cell. So when solving these values, I is equal to EMF we have given 2 volt divided by capital R 30 and small r here is suppose 10. So 2 upon 40 or 1 upon 20 amperes. So we obtain the value of current in amperes. Now check carefully. Now we know the formula of V is equal to E minus IR. So check carefully. V is equal to E minus IR's potential across external resistance or potential of voltmeter, potential across voltmeter, that is equal to E minus IR. So that formula already we have learned in 11th standard and also 12th also, same chapter. So V is equal to 2 minus EMF 2 minus current will be 1 upon 20 into small r 10. So what we obtain here is 0 will be get cancelled here. So 1 by 2 means 0. 2 minus 1 by 2. So this is obtained 3 by 2 here. So the answer is either 1.5 or 3 by 2. So that will be the reading of voltmeter. So that is very simple here. You try to solve by yourself. Just check the solution and practice the same solution here. Okay, number next. What we have given, a set of 3 coils having resistance 10 ohm, 12 ohm and 15 ohm are connected in parallel. This combination is connected in series with series combination of 3 coils of same resistance. So the understanding is very important in this problem. Check carefully what we have given. A set of 3 coils. So we have set of 3 coils in which first is 10 ohm, second 12 and third 15. Initially connected in parallel. So one set having 3 resistance all connected in parallel. Now check carefully, second sentence is very important. These combination means which combination? Parallel combination of all the three. This combination is connected in series with series combination of three coils. So parallel combination means this combination is connected in series with series combination of three coils. Means we have 10, 12 and 15 we have to connect in series, and in that we have parallel combination again connected in series. So the combination is given like this: one parallel resistance of 10, 12 and 15, and that will be connected with series of 10, 12 and 15. So there are four equivalent of parallel combination RP suppose. So 10, 12, 15 connected parallel to each other, and then we have 10, 12 and 15 connected, 4 will be connected in series. Calculate total resistance and current through the circuit if a battery of EMF is 4.1 volt is used for drawing current. Now check carefully. In short, we have given this particular diagram here. Check carefully. So initially connected in parallel means 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Parallel formula we know that. So 1 upon Rp is equal to 1 upon 10 plus 1 upon 12 plus 1 upon 15. Solving or taking LCM, we have 6 plus 5 plus 4 and LCM 60. So 1 upon Rp is equal to 15 upon 60. So Rp is equal to 15 will be cancelled with 4. So 1 upon Rp is equal to 1 upon 4 or Rp is equal to 4. So parallel combination of the three will be obtained as 4 here. Now check carefully series resistance, a series combination. So series combination of Rp means 4 plus first resistance R1, then R2 and R3, 10 plus 15 plus 12 and plus their parallel combination means Rp is equal to 15. All these we have to connect in series. So how much is total resistance? So total resistance R is equal to Rp plus R1 plus R2 plus R3. And in terms of numbers, 4 plus 10 plus 15 plus 20. So we obtain 41 ohm like this. Now check carefully. Total resistance is our first answer. Calculate total resistance. So R is equal to, effective resistance is equal to 41 ohm. Now current I is equal to V upon R. And we have battery EMF is 41. So, sorry, 4.1. So EMF in volt 4.1 and resistance R is 41. So 4.1 divided by 41 is 0.1 ampere. So this is answer. These problems are very easy. You have to practice. So already we have learned this resistance in series, resistance in parallel. That formula already we learned in previous standard. So these problems of current electricity are not much difficult. Okay, now check carefully the number next. Read carefully what we have given here. Okay, now next problem, check carefully. A potentiometer wire has a length of 1.5 meter and resistance of 10 ohm. It is connected in series with the cell of EMF 4 volt and internal resistance 5 ohm. Calculate potential drop per centimeter of the wire. Once again, what we have given the values, check carefully. Length of potentiometer wire 1.5. Resistance of wire is 10 ohm. It is connected in series with the cell of EMF 4 volt. So EMF is equal to 4 volt and cell having internal resistance 5 ohm. Now in that case we have to find the potential drop per centimeter, means potential gradient, that we have to calculate per centimeter, means potential drop per centimeter, that we have to calculate for wire. Now check carefully the solution is given like this. Now check carefully. What we have given: length 1.5 meter, resistance 10 ohm, cell 4 volt, internal resistance 5 ohm. We need to calculate the current using these formula. So I is equal to E upon R plus R. So current I in the circuit is total EMF E divided by total resistance. So total resistance means resistance of wire and internal resistance of cell. So E upon R plus R, when we replace the values in case of this, so I is equal to EMF 4, capital R 10, small r 5. So solving this, we have I is equal to 0.267 ampere. So we calculate here is I. Now we need to calculate the potential or potential across wire, and then we use a formula for Ohm's law. V is equal to I into R. So potential across the potentiometer wire, V is equal to IR. Current I is 0.267 and R is given as 10. So we obtain V is equal to as 0.267 into 10. V is equal to 2.67 volt. So we need to calculate the potential drop per centimeter of wire using formula potential drop per centimeter. So we obtain potential difference, and now we use potential drop per centimeter means V upon L. So that L we have to convert in centimeter, L we have given in meter. So meter to centimeter conversion is important. So potential drop per centimeter is equal to potential V 2.67 divided by 1.5 length, and if it is converted into centimeter, so multiply by 100 meter. 1 meter is equal to 100 centimeters, so multiply by 100. So solving this, we obtain potential drop per centimeter is equal to 0.0178 volt per centimeter. So such type of problem asked in examination, and these problems are easy compared to chapter problems from other chapters. Okay. Now we have the next simple problem. Check carefully. Also very easy. When two cells of EMF E1 and E2 are connected in series, so as to assist each other, their balancing length on potentiometer is found to be 2.7 meters. So see here what we have with assist each other means addition of EMF. E1 plus E2 balancing length will be L1 suppose 2.7. So that we write here L1 is equal to 2.7. Now when cells are connected in series so as to oppose each other. Oppose means we have to subtract EMF, and in that case balancing length is found to be 0.3 meter. And in that case we have to compare the two cells. So L1 is equal to 2.7 meter, L2 is equal to 0.3 meter. And if we have the formula from the comparison of EMF method number 2, so E1 upon E2 is equal to L1 plus L2 divided by L1 minus L2. And if we solve 2.7 plus 0.3, 2.7 minus 0.3, 3 upon 2.4. So this will be solving 1 upon 0.8 or 10 upon 8 or 1.25. So the ratio of EMF will be, or comparison of EMF is equal to 1.25. Okay. Similarly, we have a very easy problem. The EMF of cell is balanced by length of 120 centimeter of potentiometer wire when cell is shunt by resistance of 10 ohm. The balancing length is reduced by 20 centimeter. Find the internal resistance of the cell. Now check carefully. Length L1 is taken as given as 1.20 centimeter L1. Now check carefully, when cell is shunted by resistance 10 ohm, the balancing length is reduced by 20. So we have initial length 120. Here we have the important problem and student makes mistake. So second length is, we have to calculate like this. Balancing length is reduced by 20. And student directly take as L2 is equal to 20. So that is not the case here. Balancing length is reduced by 20 means L2 is equal to initial length L1 minus 20. Initial length is 120. So 120 minus 20 is equal to 100 centimeter. So here we have the important part. So reduced by 20 means 120 minus 20, 100 centimeter. Now R is given as 10 ohm. Now Now next part is very easy. You know the formula. R is equal to small r internal resistance is equal to capital R L1 upon L2 minus 1. So that is the third application of potentiometer. So to find internal resistance of cell using potentiometer, from that we have the formula. Now by replacing the values 10, 120 divided by 100 minus 1, 0, or we cancel 1.2 minus 1, then 10 into 1.2 minus 1 is 0.2, that is 2 ohm. So we obtain a resistance is equal to 2 ohm. So problems are very easy, and such type of problems asked in examination also, board exam also, and in CET, JEE and NEET also. Only thing is sometimes we make mistakes. So here is important part, balancing length is reduced by 20 and sometimes we take L2 as 20. In that case we have make mistake of note down the length. So reduced by 20 means initial length 120 minus 20, that is equal to 100 centimeters. So check carefully. So before writing given, you should read 2 times the problem and then accurately write down given, then use formula and calculations, then result and proper unit we have to mention here. So that are the steps of solving problems. Okay. So here we finish up the chapter of current electricity. So check carefully all the lectures, try to note down your notes and prepare accordingly the topics as the chapter, this chapter doesn't have any reduction, means in other chapters we have certain 25% syllabus reduced, but in this chapter there is a complete syllabus, nothing is reduced from this chapter, so you have to prepare whole chapter and all topics are important here. Thank you.